Okay, welcome to my tutoring video on molecular geometry. So we're going to be starting with the molecular geometries that have 4 electron domains. So here they are drawn in the simplest form. So to start, this is when you have 4 electron domains and no lone pairs. This one is called tetrahedral. Tetrahedral doubles as an electron domain and a molecular geometry. So tetrahedral is the electron domain for all these 3 too. So I'm going to show an example of tetrahedral. So if you have 1 silicon and 4 hydrogens, if you look at it, silicon has its octet and each of their hydrogens has its 2 electrons. So if you count, you've got 1, 2, 3, 4 electron domains, and none of them are lone electron pairs. They're all single bonds, and that is tetrahedral molecular geometry. So if you move on to the next one, this is Trigonal Pyramidal. This is when you still have 4 electron domains, but you only have 1 pair of lone electrons. And then next, if you take away another bond, you're left with 2 electron domains. This is what is called bent. So it still has 4 electron domains, and I'll show an example of that one. So if you have sulfur with 2 hydrogens, you've got your 2 hydrogens with their 2 electrons with the single bonds, and then you've got 1 lone pair of electrons above and 1 below for sulfur so that it has its full octet. So if you count, it still has 1, 2, 3, 4 electron domains, but 2 of them are lone pairs, and that's what gives you the bent molecular geometry. And then the last one is called linear, and that is if you have 3 lone pairs of electrons. So you would only have 1 bond and then 1, 2, 3 electron pairs. So that is for 4 electron domains. These are all the possibilities you could have. Next, we're going to move on to if you have 3 electron domains. Thanks. This doesn't erase very well. Okay, so for 3 electron domains, there are 3 options that you can have. So that's easy to remember. Okay, so to start off, if you have no lone electron pairs, this one right here is called Trigonal Planar. So Trigonal Planar is when you have all 3 no electron pairs, but you've got your 3 electron domains. So an example of that is 1 boron with 3 fluorines. And remember that it is boron the moron, which means it only needs 6 electrons to have an octet. So this is how you would draw that Lewis structure. So you've got your 1, 2, 3 electron domains, which is what puts you in the trigonal planar region. And none of them are lone pairs, which is what makes it trigonal planar for your molecular geometry. So next we have bent. So yes, this is the same name as the one from 4 electron domains, but the one with 4 has 2 pairs of lone electrons, while this one only has 1. So an example of that is going to be 1 nitrogen with 2 oxygens. This one is a little abnormal, but it still works as an example. So when you draw the Lewis structure of that, you've got nitrogen. It has only 1 lone pair, one lone electron above it, due to it has an odd number of electrons. And then you've got a double bond over here and a single bond over here for the oxygens. So if you count, you've got your 1, 2, 3 electron domains, which is why you would have these 3 options, but you have that 1 lone electron. Normally it would be 2 electrons making a lone pair of electrons, but in this case there's just 1, and that is what makes it bent. There's not 2 extra that would put you in bent for tetrahedral. And then finally you have linear, which again is also present in when you have a tetrahedral electron domain, but again this one only has 2 pairs of electron domain in contrast to 3. So those are all the, no, that's called linear. So those are all three options that you can have if you have 3 electron domains. And now we're going to move on to expanded octets, because those can obviously happen. So for expanded octets, we're going to start with if you have 5 electron domains. So there's going to be 4 options for that. And so, one moment. All right, so when you have 5 electron domains, you're going to start off with Trigonal Bi-Pyramidal. Trigonal Bi-Pyramidal. So that's when you have 1, 2, 3, 4, 5 electron domains. So, yeah, and that's when you have no lone pairs of electrons, but you can count and you have 5. So, I'm not going to give an example of that one, but I am going to give an example of the next one, which is called Seesaw. So this molecular geometry still has 5 electron domains, except it has 1 lone pair of electrons. So an example I'm going to give of that is 1 sulfur, and then you're going to have 4 fluorines. Oops. Ooh, this does not erase well. You're going to give each of these fluorines its octet. And then if you add all that up, so you have 4 fluorines, and each of those has 7 valence electrons, so then you've got 28. And if you add 6 valence electrons for sulfur, that gives you 34. And if you count how many we have, we've got 8, 16, 24, and then 32. So that means that we need 2 more, because we need 34 electrons. So you're just going to put that extra pair right on sulfur. And so then if you count, you've got 1, 2, 3, 4, 5 electron domains, because that extra electron pair counts as an electron domain. So that is what is going to give you Seesaw. Next over here we have T-shaped. It's pretty easy to see why that's T-shaped. If you turn it sideways, it looks like a T. So that's what that one is called. And I'll give an example of that one too. So T-shaped, I'm going to give the example of 1 bromine with 3 fluorines. So I'm going to give each fluorine an octet. And then if you count these up, so you're supposed to have 3 fluorines, so that's 3 times 7 is 21. And then bromine adds another 7. So now you've got 28, but if you count, you've got 8, 16, 24. So we still need 4 more electrons. So those you're just going to add right onto bromine. You're just going to add 1 pair of electrons and 2. And then you have everything you need. So then when you count them, you've got 1, 2, oops, there's the bond, 3, 4, and 5 electron domains when you count. And since you have 1, 2 lone pairs of electrons, that leaves you with T-shaped. And then once again, you have linear. And linear is for this one, you're going to have 3 lone pairs of electrons. So if you've noticed the trend in the linears, it's always just you've got like a straight line, and then you've got lots of extra electrons around it. So this one has 3 extra pairs of electrons. And those are all your options for if you have 5 electron domains for an expanded octet. And finally, we are going to do the molecular geometries for if you have 6 electron domains. So for this, there are only 3 options. So give me a second to 1, 2, 1, 2. All right, so these are your options for if you have 6 electron domains. You've got 3 up there, 1 up there, and then your central molecule. So the first one is called octahedral. So that is what your electron domain would be called for all of these, because you've got 6 electron domains. So an example that you could give of that, what is PF6 with a -1 charge? So that you would have 1 P in the middle, and then you would have 6 fluorines coming off of it. And then for time's sake, I'm not gonna draw all the electrons around it, but each fluorine would have an octet. And if you count here, you've got 1, 2, 3, 4, 5, 6 electron domains. And all of them are bonds, none of them are lone electrons, and that is what gives you octahedral. So next, as you can see, we've got 1 lone pair of electrons on this one, and this one is called square pyramidal. So square pyramidal still has your 5 electron domains, but it's got one of them is a lone pair. So for that, I'm going to give the example of 1 chlorine with 5 fluorines. 2, 3, 4, 5. And so each of these is going to have an octet. All of the fluorines will have an octet. All right, I think that's, yeah. So chlorine and fluorine are both in that, they both have 7 electron, valence electrons. So if you do 7 times 5, you've got 35. And if, wait. Yeah, so 7 times 6, sorry, 42. Because you've got 5 fluorines and 1 chlorine. So you've got 42 electrons needed, but if you see that each of these has 8 so far, all the fluorines, so if you do 8 times 5 of all these fluorines, you get 40, so we need 2 more electrons. So we're just gonna add those onto the chlorine because they always, the extra electrons always go on the central atom. So now you've got 1, 2, 3, 4, 5, 6 electron domains. And then you've got that 1 extra pair there. So that would give you square pyramidal. And then finally, your last molecular geometry, if you have 6 electron domains, is called square planar. So if you've got square planar, obviously you've got your 6 electron domains, and 2 of them are your extra pairs of electrons. So for that one, I'm gonna do xenon with 4 fluorines. So if you've got your 4 fluorines, that's going to give you a total of 28 electrons, because that's 4 times 7. Fluorine has 7 electrons. And then you've got your xenon, and that has 8. So if you've got 28 plus your 8, you're now at 36. But if you count this up, you've got 8, 16, 24, and 32. So we need 36, which means we need 4 more electrons. So, yeah, so then we would add 2 more electron domain pairs here. So then you've got 1, 2, 3, 4, 5, 6 electron domains, and 2 of them are electron pairs, which gives you square planar. So those are all of your options for if you have 6 electron domains, and yeah, that is how you do molecular geometry.